All the examples we've used so far have been for one criterion and one predictor variable, or one DV and one IV. There is also a case of regression where more than one predictor, or IV, is used to predict a particular outcome. We're talking about the relationship between two variables. We're talking about a bivariate correlation or bivariate regression. When we're talking about the relationship between more than two variables, we're talking about multiple regression or factor analysis. What I'm going to talk about today is multiple regression. If one variable can predict an outcome with some degree of accuracy, then why couldn't two do a better job? So multiple regression is when there's still only one DV, dependent variable or criterion, and a set of independent variables or predictors. For example, in a bivariate regression, you may have hangover is equal to A plus B1 drink. So here you would expect B1 to be positive. In other words, the more you drink, the worse your hangover or the bigger your hangover. But you might have a good reason to add a second variable, such as hydration. So multiple regression may look like this. Hangover equals A plus B1 drink plus B2 hydration. So here you would expect B1 to be positive. In other words, the more you drink, the worse your hangover or the bigger your hangover. And B2 to be negative. In other words, the more glasses of water you drink the night before, the less hangover you may expect to have. In a bivariate regression, you may have nerdiness is equal to A plus B1 love of stats. So here you might expect the coefficient B1 to be positive. In other words, the more you love stats, the more nerdy you may be on some measure of nerdiness. But you might have good reason to add a second variable, such as time spent socializing. So a regression may look like this. Nerdiness is equal to A plus B1 love of stats plus B2 socializing. So here you might expect the coefficient B1 to be positive. In other words, the more you love stats, the more nerdy you are on some measure of nerdiness. And B2 would be negative. In other words, the more time you spend socializing may be related negatively to some measure of nerdiness. So in bivariate regression, you may have another example. Number of dates is equal to A plus B1 attractiveness. So here you might expect the coefficient of B1 to be positive. In other words, attractiveness is related positively to the number of dates. But you might have good reason to add a second variable, such as personality. So multiple regression may look like this. Number of dates is equal to A plus B1 attractiveness plus B2 personality. So here you might expect B1 to be positive. In other words, attractiveness is positively related to the number of dates you get, and B2 would be positive. In other words, if your personality is about as exciting as pulling teeth, then you'd expect the number of dates not to be high. But if you have a very positive personality, then the number of dates may be positively related. And we may have reason to add more variables if there's reason why, such as what you can see here. As you may have guessed, this is called multiple regression. So multiple regression is when there is still only one dependent variable or criterion and a set of independent variables or predictors. So at the conclusion of this lecture today, your objective is to have a thorough understanding of the following. I'd like you to have an understanding of the purpose behind multiple regression, some of the common features of multiple regression. I'd like to talk a bit more about the multiple regression equation, what the residuals are, and when there are correlated and uncorrelated predictors, and how that impacts on multiple regression. I'm going to also look at the standard multiple regression, so I'm not going to go into sequential multiple regression or hierarchical multiple regression. That's not part of this lecture or indeed this course. I'm going to look at some of the assumptions and put pitfalls around standard multiple regression, and also talk about SPSS and the interpretation of the output of SPSS that arises from multiple regression.